we'll see what is a homologous series. Homologous series is a series of compounds in which the same functional groups substitute for hydrogen in a carbon chain. Simply, homologous series is a series of organic compounds which differ from the next compound by CH2. Now I'll explain you with the help of an example. Now here is a homologous series that is present. If you look at all the compounds, they have the same functional groups attached to each hydrocarbon. So here you will see chlorine. Even here there is chlorine, chlorine and chlorine. And if I take these two compounds, see, and I compare it, so here there is one carbon, here there is one extra carbon. Okay, so only difference of carbon is by one. If you look at the difference of hydrogen atom number, here it differs by it. The next compound has two more hydrogen carbon than the earlier one. So हांगा हे दोन्ही compounds भितर difference जो आसा तो CH2 चो आसा. That is एक carbon हांगा extra आसा आणि हांगा दोन hydrogen atom extra आसा. If आता समज हो आणि हो compound पळयता आमी, again the second and the third compound, परत एक कार्बन आणि दोन हायड्रोजन ॲटमाचो डिफरन्स पळयतले. जशें हांगा C2 आणि C3. एक कार्बन एक्स्ट्रा, H5 आणि H7, दोन हायड्रोजन ॲटम एक्स्ट्रा. सो हे सिक्वेन्स इन अ होमोलोगस सिरीज पळोवपाक मेळटले. That's why the series is called as homologous series. First of all, they are being substituted by same functional group, and there is a difference of CH2 in each compound, in each succeeding compound. Now, if I look at this series, the general formula of this will become CN H2N plus 1, like over here for N is equal to 1. Value of H is 3, that is 2 into 1 plus 1, H3 and Cl. So only for this series the general equation is this. So I can get the next compound by substituting N is equal to 5. So my next compound will be C5 H, 2 into 5 10 plus 1 11. So C5 H11 Cl. So two homologous compounds differ by CH2 unit and by mass 14 mu. Now homologous have same chemical properties as they have same functional group. I have already explained that if a compound is getting substituted by a particular functional group, then the property or the chemical properties of whatever the functional group is having, it will get the resulting hydrocarbon will get the same property as that of the functional group that is attached to it. So आता समज एक हायड्रोकार्बन आसा तेका क्लोरीन अटॅच जाला. सो क्लोरिनाचो जो एक्चुअल तेजे बिहेवियर, तेजे केमिकल एक्टिविटी और रिएक्टिविटी कितें कितें आसा तो सेम आता हायड्रोकार्बनाक मेळटले ते सगळे प्रॉपर्टीज. So homologous will have same chemical properties because in each and every compound the same functional group is attached. Now the second thing is physical properties vary gradually as melting and boiling points increase when the size of the compounds increases. आता हो first compound is CH3Cl, second is C2H5Cl. हेजे परस हो मातसो bulky जालो. आता next compound is much more bigger than the previous one. So अशें करून in a homologous series जशे जशे मुखार वता तशे तशे तेजे size सुद्धा increase जाता. So the boiling आणि melting point म्हळ्यार कितें basically bonds break करपा try करता. So as the size of compound increases, naturally melting and boiling point of that particular compound as you go in higher compounds, it will go on increasing. So this basically changes the physical properties. So hence we say that this series have same chemical properties because of same functional group, but different physical properties depending on the size of the compound. So here are some examples of homologous series. So homologous series, basically it will be related to only one functional group. So the first set is of alkane. So here is one series, CH4 methane, ethane, propane. This is one homologous series because the functional group is that of a single bond. This is the second homologous series that is related to double bond, ethene, propene, butane. Again you will see the difference of CH2 in all the sets. You will see the difference of CH2 unit. Now this is a homologous series that is related to alcohol group, methanol, ethanol, propanol, butanol. Then the last series that is shown over here is that of the functional group carboxylic acid, COOH. First one is methanoic acid, 1 carbon. Second one is 2 carbon ethanoic acid. So again in each and every, between each and every compound here, you will see the difference of CH2 unit. So we will look at few chemical properties of carbon compounds. The first property is combustion. So we already know what is the meaning of combustion, that is burning in the presence of oxygen. So that is basically the meaning of combustion. So carbon compounds generally burn, or in other terms we say it as oxidized, because it is burning in the presence of oxygen. So it burns in, so carbon compound generally burns in air to produce carbon dioxide and water and release heat and light energy. So here there is one carbon compound, that is methane, CH4, that is burning in the presence of oxygen. Whenever we say burning in air, it indirectly means that it is burning in the presence of oxygen. So it is 2O2. The reaction goes forward to give carbon dioxide and water, two molecules of water. So this is combustion reaction or oxidation reaction. I say oxidation because here if you see that carbon is getting oxidized to form carbon dioxide. Now we'll see what happens in saturated and unsaturated hydrocarbons. We have already seen what is the meaning of saturated and unsaturated hydrocarbons. So when saturated hydrocarbon, that is hydrocarbon having single bonds, when it burns, it will give blue flame in good supply of air. So it will generally give clean flame. By clean flame I mean that blue flame here, like this, in the presence or in good supply of air. Now the gas or kerosene stove that is used at home has inlets of air. If you see the burner and all, it will have tiny inlets of air. So this helps in getting sufficiently good amount of oxygen rich mixture that will burn, and in turn it will give a nice clean blue flame. That blue flame tells you that there is a complete combustion process that is taking place. Now when that supply of air is limited, there comes incomplete combustion. Okay, so whenever there is an incomplete combustion, you will see a sooty flame. A sooty flame will be seen because there is limited supply of air for the combustion to take place. Now sooty means generally you will see that blackish smoke. Now this is vastly seen in the case of unsaturated hydrocarbons. So in unsaturated hydrocarbons, you will see yellow flame with black smoke. So it results in a sooty deposit on the metal plates at the bottom of cooking vessels. Now you might have seen in most of the vessels that is getting heated, especially on wood, you will see that the bottom layer of the utensils will have, black deposits. If you just touch the bottom surface of the utensil, your hands will turn black. Okay, so that is called as the sooty deposit. So that happens in the case of unsaturated hydrocarbon, or even in the case of saturated hydrocarbon, but when the supply of air is very limited. By limited I mean that there is little amount of air that is getting supplied over there, not completely absence of air. So in some cases air holes are blocked and fuel gets wasted. Now, fuels like coal and petroleum have a certain percentage of sulfur and nitrogen in it. So, when the combustion takes place, okay, so during combustion, oxides of sulfur and nitrogen are formed. For example, sulfur dioxide, nitrogen dioxide. So, these harmful gases are formed when such fuels are burnt. Okay, so this is responsible, or these are indirectly the major pollutants in the environment, and that is indirectly responsible for acid rain. The next chemical property is oxidation. We have seen how carbon compounds get easily oxidized on combustion. Here we see an example of oxidation, and by oxidation I mean that there is addition of oxygen to a compound. So reaction that involves addition of oxygen to a compound are termed as oxidation reaction. Now over here you will see how alcohols are converted into carboxylic acids with the help of some special substances. Now these special substances that is helping the alcohol to get converted to carboxylic acid, it is called as oxidizing agents. So these special substances are called as oxidizing agents that have the capability of adding oxygen to other compounds. Now in this example over here, oxidizing agents are alkaline KMNO4, and the common name for this is potassium permanganate, or there can be acidified K2RCr2O7. It is also called as potassium dichromate. So these two are oxidizing agents that are taking part in this particular reaction. So what happens is oxygen is getting added over here. Here some bonds are broken. Here this bond will be broken and oxygen will be added to form this compound. So here 2 carbon means ethanol is getting converted to ethanoic acid. So here are some more examples that is related to methanol. Again oxidation with potassium permanganate as an oxidizing agent. Remember that the number of carbon atoms remains the same. Only thing, there is a change of bond formation with respect to hydrogen and alcohol functional group. So methanol is getting converted to methanoic acid. So this conversion of alcohol to carboxylic acid only takes place in the presence of these specified oxidizing agents, and this we have already seen above. Ethanol getting converted to ethanoic acid with the presence of acidified potassium dichromate. So it should be either of the two as an oxidizing agent for this type of reaction to happen. So this is an example of oxidation that is taking place with respect to carbon containing compounds.